Hey, Walker. How are you?
I'm good. Oh, wait a second. Can you hear me?
I can hear you. How are you doing?
I'm good. I didn't realize if this computer had a microphone. Apparently it does. Can you see anything?
No, it's just red.
Okay. Yeah. Adjust it.
But
what do I know?
Well, hey, there you are. I'm too shy to show my face.
Hey.
So I just show a picture.
Ah. I don't know.
But I guess I could show my face. I'm just shy.
Yep. So I had a question for you. Did you see my quiz on on the Google Doc thing, the take-home quiz?
I haven't even looked at those yet because a lot of people were panicking about getting them done.
Okay.
So, and I gave everybody till midnight last night, so I didn't even bother to take a look at them. I was going to do that later today, just in case anybody needed a little bit of extra time. I'm sorry. You have a question?
Oh yeah, I was unsure if I submitted it, so I don't think I did actually. So I'm kind of going through and redoing the quiz. It's like, oh snap, it was one of those things.
Okay, well let me go through. Let me go and check. Hold on. Do you mind waiting just a minute?
Oh, no problem.
How are you doing today?
It's been a very busy day.
Oh, amen. I'm right there with you on that. Totally. I mean, seriously, like I feel like I'm moving from one thing to the next and I'm just staying in a state of sheer panic.
Mm-hmm. Yeah, we have 2 tests tomorrow. I think a project due tomorrow, a few different terms and stuff like that. So it's kind of like, whoa, everything kind of hit at once.
Oh, I'm sorry, buddy. I'll be praying.
Thank you.
About that.
So is everybody going to, is it like kind of like a group chat when we do this? Because this is the first time I've done a math lab.
Yes, that's what it's supposed to be. So, indeed, that is what it is supposed to be.
Okay.
But if you have questions, you know, or anything like that, you know, this is where I answer them.
Yeah, so I had a few questions about the division problems for one was here.
You're out. Okay. You do have some questions?
Yes, I do. Let me see. I think it's 1.7. Let's see here. I'm checking through my book right now. So. Which section was the division problems? Was it? I thought it was 1.
That was earlier on. Like when you say division problems, are you referring to the ones with the radicals on the bottom, or?
I think so, yes. Wait, I think that might have been 1.5 actually.
I think you're right.
Oh, yeah, here we go. Rationalization demonstrators of fractions, or they use properties of square roots and stuff like that. But it's basically just been that. You know.
Okay.
And so basically the example is 3 over 7 plus the square root of 2. And it's, how to put that in a more simple term or in standard form.
Okay, let me get that from you again and write it on a piece of paper. And then I'm going to try to figure out how in the world I can show it to you. Bear with me.
Here, hold on. I'm going to go get some headphones for this.
Okay. Would you mind reading the problem to me again?
Oh, sure, no problem.
Or tell me what page it's on?
It's on page 33. The problem reads 3 over 7 plus the square root of 2. That's the example that they give me. And then later on, they have on page 35, like 5 over 16, the square root of 5 over 16, and other stuff like that.
Okay. All right. Let me pull my book, and I'm going to take a picture of the actual page and then pull it into Paint and see if I can write on it. Because the book online prevents me from, and then I'll share my screen with you, but the book online unfortunately prevents me from writing directly on like a PDF or on the screen, unfortunately. So that's why I wanted to specifically go to the place where you had the question, and then I can pull some of those examples up.
So yeah, it was page 35 was where some of the problems were, and 33 was where the example was. It was example 2.
Okay. Headed your way.
I think things should
Basically,
get a little easier in the future.
Yeah. Yes. Yeah, I know. And I'm hoping they're going to get me something that I can actually write on.
Yeah,
And please stop me in class, or even I can come back and sit at your table group and write out examples. I'm always happy to do that. But let me kind of, as I'm pulling this up, let me kind of explain behind what about simplifying radicals and those expressions. Let me explain the premise behind that a little bit to you, is the fact that you cannot have, sorry, my computer's making some noises at us because I just took a screenshot of the page. You cannot have, it's one of those things like dividing by 0. You're not allowed to have radicals in the denominator. That's a no-no. So when it asks you to simplify a radical, it's really basically saying we wanted to get it in its smallest terms. And in addition to getting in its smallest terms, we want to not have radicals in the denominator. Okay, so now I have that pulled up in Paint, so I'm going to share my screen with you. And hope it works. If you'll pray with me, I'd greatly appreciate it.
I don't know. Google Chrome doesn't necessarily have the best of software. It's all free though, so that's kind of a plus.
Yeah, we're definitely. And then it looks like you're going into a bunny trail. I call it Alice in Wonderland and the rabbit hole as you travel on. But do you see the 1.5 exercises on my screen?
Yes.
Okay, cool. All right, so let's just start with something simple, and then we'll move to some of the more complicated where you have to have the conjugate. So I'm just going to go ahead and pick number 11, okay, first. All right, so there's a radical in the denominator, the square root of 3. Okay, and I'm writing on my screen, so hopefully you can read my writing because it's really not always the best, and it's even worse on the screen. Would you agree with me? Would you agree with me that you can multiply anything by the number 1 and it doesn't change its value?
Yeah.
Okay. So what I want to do in order to remove the radical from the denominator is multiply the top and the bottom by the square root of 3 over the square root of 3, because technically that's just has a value of 1, because any number over itself is 1. So, and in order to get rid of the radical down here on the bottom, if I multiply both the top and the bottom by the square root of 3, then I'm actually going to eliminate the radical on the bottom, because when I multiply the square root of 3 times the square root of 3, I'm just going to get 3. Does that make sense to you or not really?
Yeah.
Okay.
So
now
3 times 3 equals, just 3.
Yes, sir. Yes, sir. And so that, believe it or not, it doesn't look a lot prettier, but to a mathematician, that looks prettier because there's no radical in the denominator. So when you see the instruction, simplify radical expressions, it's merely asking you, is it in its smallest form, like most reduced form, and are there no radicals in the denominator? That's essentially the question it's asking.
And so,
okay,
what you'd have here is basically just the quote-unquote simplified version, the completed version. And would you have to take it a step further and try and do anything else after the step, or no? It just
no, sir. That's it. And that's why I said it doesn't really appear much prettier and almost a little more complicated than the beginning problem. But believe it or not, it's simplified because the no here is no radicals in the denominator.
All right, so
okay,
do you think we could go over number 18, which, the 3 plus 7, the square root of 7, and that?
Absolutely. Let me see how I can. I'm just going to see if I can just undo all of this. So bear with me as I erase my work and we start over. Okay. All right. Now, with number 18, once again, we want to get that radical out of the denominator. The denominator is really our focus. And so what we're going to do here, once again, we're going to be multiplying the entire fraction by a form of 1. Because anytime we multiply something by 1, we're not changing its value. So we start out with this. As our original problem. But now what we want to do in order to get rid of the radical in the denominator, which this denominator here, it's not just simply a radical, it's called a complex number because it has a real regular number and it has a radical in it. And those can't be combined. It's almost like if you could think of the square root of 10 almost like a variable, because the square root of 10 is a very precise measurement. We could actually simplify it by taking the square root of 10 on our calculator, but believe it or not, a more precise number is just by saying the square root of 10. Does that make sense? Okay. So what we're going to do is multiply the top and the bottom by its conjugate. Believe it or not, that's supposed to be a dot for a multiplication. And the conjugate of 2 minus the square root of 10 is 2 plus the square root of 10. And so the reason why, I'm sorry, say that again.
I see how you're getting, rid of the 10. because you have that. But would you also have the reciprocal of the 2 to try and get rid of the 2, or could that just stay where it's at?
It can stay just fine. The only thing great question. The only thing you need to change is that middle operation. Just if it's minus, it goes to plus. If it's plus, it goes to minus. And I'm going to explain why up here. Hold on just a minute. Let me try something. I'm hoping this will work. I'm going to see if I can cut this out to give me some additional workspace up here. Okay. The reason, oh, whoops, I only go back to writing. The reason why I can do this is remember back when about foiling. Are you familiar with foiling?
Yes, ma'am.
Okay. And remember, do you remember the difference of two squares where that middle term gets canceled out? Does that ring a bell or not really?
Kind of.
Okay, well, when we FOIL this, we've got 2 times 2, which is 4, right?
Mm-hmm.
And then this right here would be minus 2 times the square root of 10. And then we've got this here, which is going to be plus 2 times the square root of 10. And then on the very end, we've got this negative square root of 10 times the positive square root of 10, which then gives us the negative 10. Do you agree?
Mm-hmm. Yes, ma'am.
Okay. So this middle term right here cancels out. So we're really left with 4 minus 10. And that's the whole reason that you want to multiply by the conjugate, because you know this middle term is going to cancel out, because by multiplying by the conjugate, you're actually creating the difference of two squares. Does that make sense?
Yes, ma'am.
Okay, so now you've got 4 minus 10, which is what?
4 minus 10, which would equal negative 6.
Yes, sir. So now the complicated part, the next part, not really complicated, but once again, we're going to FOIL these two at the top, the numerators. So we've got 3 times 2, which is what?
3 times 2 is 6.
And then you've got the square root of 7 times 2, which is plus 2 times the square root of 7. And then we've got 3 times the square root of 10. And then our last term, which I might not be able to get on here, is the square root of 70, which I can't really get it on there. I'm sorry. I got it too tight. Let me see if I can erase that and start over and move it over a little bit more, okay? Okay, so I've got 6, which was 3 times 2, times 2 times the square root of 7, plus 3 times the square root of 10, plus, and now I'm multiplying the square root of 7 times the square root of 10, which is square root of 70. Okay? And I'm just going to factor that. I think there might be room over here. I don't know if it'll, 2 gives me 35. And then that gives me 5, 7. So really, it's in its lowest form because I can't pull out any perfect squares. So believe it or not, 6 plus 2 times the square root of 7 plus 6. The only thing I did wrong.
My sister's calling my name. Okay. Emily, I did let the dog out. Yes. Okay. He's in his kennel right now. I fed him and I did all that stuff, but he's sleeping. Sorry about
Okay. So, oh, no, you're fine. Good, responsible person taking care of your baby doggy. Anyway, believe it or not, that looks like more of a train wreck than the original problem, but that is your final answer.
Mm-hmm. Okay, so I'm kind of seeing how it's basically, it's getting rid of all the radical numbers, and it'd be the same as foiling.
Yes, that's it exactly. And then, so that's the more complicated. I want to make clear though, do you understand like number 14, where you have to factor it first and then get rid of the radical? Does that make sense?
Oh, yes. Mm-hmm.
Should I do that one?
I think, I don't know, I was kind of checking over some of it in the book.
Yes, sir.
Because kind of, what is it? They transformed it into the square root of 13 over the square root of 28, and then they multiplied by was it 28? Like the square root of 28 on both
Yes.
sides. Okay, so I think I'm doing. Do you think we should go over?
You could do that. Let me go over that one because that one's a little bit different. It has its own little kind of special quirkiness. Can I erase what I have now?
Yes, ma'am.
Okay. Do you feel good about that?
Yes, ma'am.
Okay. Please, I love that you showed up. You know, there's bonus points for showing up.
Oh, really? Show up more often.
Yeah. Let's see. I'm trying to undo, and you know what? I think I'm just going to do this.
I think they have an eraser thing.
Yeah, I can't ever seem to do it well. Oh wait. The eraser, I don't know. It's probably just me, to be perfectly honest with you, but
I don't know. I just basically turned on how thick you can get the eraser and then just start slamming it across the screen. Yeah.
I'm trying to, I lost my little, I'm trying to get my status bar back up. Don't like that.
Word or using
Paint.
Paint.
Yeah.
What happened there? Seemed like it was
I put grid lines on it, so I'm like, I don't know. I want my tools to show back up. I don't know where they went.
Oh, is that them right there? Like right, there's a little arrow right there.
Here?
No, I think it's the other one. I think those are the options here. Like if you go across the screen, there's one.
Yes, sir.
It's like right here, right here. On the other side.
I'm trying. I can't see you and it at the same time, unfortunately. Where?
Okay,
Try to point again.
It's like on the right side. All right. Okay.
On the right side.
Is this right or is this left? Because I think this camera's switching.
Yeah.
So are you seeing
where your hand was just then was left?
So this is right?
I went back to here.
Okay. So it's on the far right side. It's kind of tucked away in there.
Ooh. Now I've lost it all. I don't know what I did. Lord. Because there's another.
Right there. You were so close to it.
I was?
Yeah. You see there's
Oh, that's for, that was the screenshot that I took. Oh, here it is. There we go. I'm much happier now. I see where you're talking about. Thank you, sir.
Yep, no problem.
All right, let's try number 14 then. Yes, they did break it down. This is the very first step where they took the square root of 13 over the square root of 28.
Mm-hmm.
But we also have to, hang on, let me cut this away again. So I have more writing space.
Plug in my computer.
The square root, oops. The square root of 28 breaks down to 2 times the square root of 7, because this breaks down to 4 and 7. And 4 is a perfect square, which of 2 is it. So this technically would then go to 13, and then 2 times the square root of 7, okay? Because the smaller the number you're working with, the better.
Okay.
Now I only have to multiply the square root of 7 over the square root of 7, which is much easier than multiplying the square root of 28. Would you agree?
Yes, ma'am.
You know,
Okay,
because
so
I
you
like
put
this.
the 2 down there, and basically,
And then,
yeah.
yes, so I've got 2 times the 7, which that's that. And then up here, it's 13 times 7, which is 91, square root of 91.
I think so. Because 3 times 7 is 21, and 21 plus 70 is, yeah.
So the final answer is the square root of 91 over 14.
Okay. So I think I'm seeing, where it is. Because previously, when I was going over some of the answers, like, whoa, where did that come from? But I think I'm starting to, understand it a lot better.
Oh, good, good. And the other complex number with the imaginary number, same principle behind that. You're multiplying by the conjugate because you're trying to get that imaginary number out of the denominator. Same principle. And whenever you square I, you get -1 because I squared equals -1. So all of this kind of has that, I guess from our standpoint, we see the similarity, but it seems like a lot of concepts being thrown at you guys. So I kind of get that. But let's do some more. If you want to. You want to?
I mean, I don't know. I think, what time is it?
You feel pretty good?
40. I think I feel pretty good, yeah. I might go ahead and start working on some of the stuff for tomorrow. Like watch the video and stuff like that. Because, I think this really helps me a lot. Because the division was the one thing that was really giving me a lot of trouble. And I think I've figured out some of the steps.
Oh, okay. Well, I'm so glad that it helps. And please ask me tomorrow in class. And, on Thursday, same bat time, same bat channel, I'll be back. And if there is a time that works better for you, please let me know.
All right. Thank you so much, Ms. Sparks.
Oh, you're most welcome. Thank you for showing up. I appreciate all your hard work, Walker. You're a great student and fine young man.
How do you log off? Do you?
Yep. All you have to do, I think, is just sign off.
Okay.
Okay. I don't know if they told you, but while I'm driving Mackenzie to school, let me mute my microphone.